we now begin the discussion on the problem which was assigned in last lecture. It is straightforward. Only thing is that we have to apply Kirchhoff's node law here, because we are having a node from where there is a current branching, right? Except that there is nothing different. This N and C are in parallel, so this voltage is VOT, this voltage is VRT. So VRT plus VOT equal to VNT. That is quite simple, straightforward, needs no explanation, right? Then, while assuming the currents, we take help of Kirchhoff's law. So we assume current in IL, assume the direction ILT, assume ICT, and then the current through resistor we calculate using Kirchhoff's law. That is, for this node, it is outgoing, So currents incoming equal to currents outgoing. So outgoing sum is ILT plus ICT. That must be current incoming. That is, the current through resistor in this direction is ILT plus ICT, right? So VRT plus VOT equal to VNT. This VRT, now we use a property. Now here we use Kirchhoff's current node law for calculating this. Kirchhoff's mesh law. Using Kirchhoff's mesh law, we define equation 1. Using Kirchhoff's node law, what we did, there are 3 arms. We assumed current from 2 arms and calculated the current from 3rd arm using Kirchhoff's law. So Kirchhoff's law is not separately stated as an equation. Kirchhoff's law is here itself. And then we use properties of all 3 elements: resistor, inductor, capacitor. For resistor, V equal to IR. R is 1. So VRT we replace by IRT, which IRT is equal to ILT plus ICT. I think his query must have been resolved now. Ohms and all that moves. So ILT plus ICT plus VOT is equal to VNT, right? Now we use both the properties of inductor and capacitor. For inductor, it is a parallel circuit, so voltage is same. So for inductor, dILT by dt is VOT, and for capacitor, ICT is equal to dVOT by dt. So both these we use. So what do we do? But I don't find dILT by dt, I find ICT, but I don't find dILT by dt. So ILT would be means from this equation, if I have to replace it here, I need to integrate this, which I don't want. So instead of integrating this, we differentiate this. So differentiating this, dILT by dt plus dICT by dt plus dVOT by dt is equal to dVNT by dt. Now this dILT by dt is VOT, dICT by dt is d by dt of ICT, ICT is dVOT by dt, so d by dt of that is d2 VOT upon dt square plus dVOT by dt equal to this. So just rewriting what we get, final equation as just in the sequence. It is same as previous one, only thing is on right hand side we have what? Differential. In previous case, when R, L and C were there, on right hand side it was only V. Now it is dVNT by dt. This is the final equation, right? So there is one more, most complex we will elaborate, and then we shall sum up and we go for active circuits. So with this you would be so much comfortable in constructing the differential equation for any complex circuit, and once you get that, it is almost most part of the circuit theory gets over. Its solution, the different cases of input VNT, how it is applied, how it gets applied if we are having sinusoidal inputs, all those things we will discuss. So we will go for the next somewhat complex level problem now. Again, values we are taking as 1. So this is something that now nothing remains to be asked further. It's most complex now. So I think you can take few minutes and solve. Same thing. Now the Kirchhoff's node law needs to be applied, and in Kirchhoff's mesh law, 3 terms come on the left hand side. So what only thing is that now just giving names, we should take some care so that there should not be jumbling. So what we do, this now we don't give IL because you may get jumbled here. So this I will now use as I1T, this I will use as I2T, and through this there would be I1T plus I2T. This I will call as deliberately V1T, this I will call as voltage across is V1T, voltage across is V2T, and this is VOT, right? So, do you agree that Kirchhoff's mesh law will give me V1T plus V2T plus VOT is equal to V in T? I think no issues at all. What is V1T now? This is V1T. What is V1T? L di by dt. What is di? I1T plus I2, right? So L is 1. So will it be all right if I directly write d I1T by dt plus d I2T by dt? Is it right? No issue. Is it okay? I hope everybody agrees with this. Is it okay? Plus now V2T, what is the problem for me? Can I replace V2T? Can I replace V2T? V2T is what? Voltage across capacitor. Its differential is what? I1T plus I2T. So V2T is what? Integral of that, but which I don't want to use. So as I am allergic of integration, what I do? म्हणजे इंटिग्रेशन मी करायचं अवॉइड करत असल्यामुळं जिथं मला इंटिग्रेशन करायला लागतं त्याचं मी डिफरन्शिएशन करतो. अरे इज इट ऑल राईट? V2T is integral of something which I don't want. So I differentiate this to get dV2T by dt term. Is it right? So differentiating this equation, what I get? dI1 square T upon dt square plus d plus dV2T plus dVOT equal to dV in T upon T. Right now I use this to, now this I used, I will use this equal to this, right? So this I used when I put this here, this I will use when I put dV2T by dt equal to this. Now this, what is VOT? dI1T upon dt is VOT, and what is I2T? I2T is I think nothing is or here. Is it right? Now what is di by dt? VO. So this is what di by dt is VO. So its differentiation d square I to t by dt square is equal to d VOT by dt. So this term will be d VOT by dt plus now d2 IT by dt square I to t is d VOT. So it will be d cube, third derivative. What is d VOT by dt? d VOT by dt is I1t plus I2t. Right? This is V2. So d V2 by dt is I1t plus I2t. What is I2t? So I write I2t, I1t I have write as it is. Because I want to integrate it, I don't want. Plus d V0 by dt. Actually, this is this. This one is this. This one is this. This as it is. Is it right? Now, what I have got? d VOT by dt, d VOT by dt, d VOT. So, three terms are there. So, now what it is? d cube VOT by dt cube plus 3d VOT by dt plus I1t. So, I write once again because it was somewhat complex. So, d3 VOT upon dt cube plus 3 plus I1t, okay, plus 3 dVOT upon dt plus I1t is equal to dVET by dt. Now, what I don't want, I1 I don't want, I1 is here, but so we have to differentiate again, right? So this we further differentiate. So when I further differentiate, and obvious, why 4? Because there are 4, 1, 2, 3, 4 elements that will give rise to fourth power. d4 VOT by dt 4 plus 3 d square VOT by dt plus d I1t by dt is equal to d2 VOT VNT upon dt square. Is it right? What is d I1t by dt? Is VOT, right? So this is d d4 VOT upon dt4 plus 3 this is a differential equation. Is it right? So I hope that there is nothing which is such that it can't be understood. Only thing is that now these are the problems which are now becoming somewhat difficult, but obviously there is nothing such that which can't be understood. Only thing is that you have to exert more, and if you exert more, you get the answer very quickly. There is nothing, there is no learning impediment in getting final answer. Is it right? So this is called as now analysis. Means from given circuit, we are able to find out the differential equation. Now, if a differential equation is given to you, can you construct the circuit? If differential equation is given to you, can you construct the circuit would be next question. That is a very difficult task to some extent. Prior to that, we introduce few more things. Number one is that right now when I said a circuit consists of input voltage connected from outside, output voltage I can tap at any point, but this circuit is only interconnection of passive components R, L and C. R, L and C are passive components. Whereas if operational amplifier is used, that becomes an active component. For operational amplifier, I have got 3 basic lectures which I will provide you on your group YouTube sessions. Based on that, you understand everything, because that is required in active filters or active networks. But right now, you can assume that somehow there is a building block called as amplifier. An amplifier is having V in T and VOT and gain A. An amplifier of gain A means when input is connected at its input terminal, output is, what is it? VOT is equal to A times V in T, where A can be any number, any real number, positive or negative. Now if A is 1, what will happen? V in T. Now, can you tell me the difference between these two? What is the difference? There is a major difference. This amplifier input terminal draws no current. Input terminal of amplifier draws no current. It observes that voltage. This transfers voltage as it is. Where this observes that voltage and generates it here from the supply available to it. So loading doesn't take place. Means this is most important, because these two are different circuits now. This is first circuit which we discussed in the classroom. So when I connect this here, it draws current. So Kirchhoff's node law applies here. And so this is not the, when I connect it, at this point of time current is flowing through this entire current. Current is not getting diverted. When I connect this, Kirchhoff's node law gets applied, current is diverted. Whereas if I connect this through an amplifier, when I connect it through an amplifier, for an amplifier connected here, it draws no current. It just observes that, and based on that, it is a device with very high input impedance. The details you will see in the videos. So gain is 1 like this circuit and your here circuit. This this circuit, these are different circuits. This is different, this is different. Its differential equation we calculated. What is that? d2 VOT upon dt square plus 3 dVOT by dt plus VOT is equal to dVnt by dt. And this you get as dVOT by dt square plus 2 dVOT by dt plus VOT equal to VT. So this is the means the difference is this draws no current. This draws no current. So it's a scalar block, scaling or amplifying. And similarly there is one more block called as adder block. Two inputs. Again, these draw no current. Input terminals for adder and scalar draw no current. What is VOT now? V1t plus V2t. So this is a scalar, this is adder. When these two elements are used, means while constructing the circuit, if only R, L and C are used, it is called as passive circuit. And if you use either of scalar and adder or both, it is called as active circuit. Passive circuit, active circuit. For active circuit, we get huge number of permutations further. We will just go through what can be done. I am sure that you will be able to derive. It's not, as I stated that once the theme is clear, it should not be a difficult task at all. This we just use for the sake of calculating it. And the question is very straightforward, no other question. Derive the expression of VOT. The question is derive the expression of VOT, and till we get a technique, some shortcut or expertise on solution of differential equation, we don't get the answer, but we aim at constructing a differential equation. ये विचारलेलं काय आहे? VOTचं एक्सप्रेशन काढायचं आहे. आपण काढून कुठे थांबतोय? VOT बदला डिफरन्शियल इक्वेशन काढतो की जे कोणते मला नंतर सोडून देईल. Right? So the question at this point of time is derive the expression or derive the differential equation. The actual question is derive the expression for VOT, and the intermediate question is derive the differential equation in terms of VOT and VNT. Start now. You can pause the video because it will take some time for you.